Hello everyone. We will be presenting in this topic. We will be learning deadlock in operating system. Myself, Ms.Priya Shenoy from Changu Kana Thakur Arts, Commerce and Science College, New Panvel, Autonomous. So first, we will be considering what deadlocks are, the effective strategies that are used for detection, prevention and recovery of deadlocks in operating systems. So basically, deadlocks occur when processes wait indefinitely for resources that are held by each other. Understanding the necessary conditions and handling the techniques is essential for reliable systems. We will be considering the techniques that are used for preventing, detecting, and recovering the systems from deadlock, thereby reducing the which reduces the downtime and improves system availability. So, as we had said, there are four necessary conditions for deadlock to occur. The first condition is mutual exclusion, which means that resources can't be shared among the processes. Second is hold and wait, means each process must be holding some resource and it must be waiting for some another resource that is held by another process. Then third condition is no preemption. No preemption means once a process have taken a particular resource, system is not allowed to forcefully take the resource from the process. And last is circular wait. Circular wait means if there are n number of processes, P1, P2 up to Pn, then P1 will be waiting for the resource that is held by P2, P2 is waiting for resource held by P3 and so on, and final till until Pn is waiting for the resource that is held by P1. Now all these four conditions must hold simultaneously for deadlock to occur in a system. Even if we are able to break any one condition, then we can prevent the deadlock in our system and thereby improve system reliability. Now, to check for deadlock that have occurred in the system or not, resource allocation graphs are used. These graphs are basically uh, showing the resource allocation as well as the processes that are there in the system. Then there are two basic conditions or scenarios that we are considering. Suppose two processes are there, each one is holding one resource and it is waiting for another resource, another process. Then in that case, deadlock will occur. Another example is database locking with circular waits or printer or file access contention. Prevention strategies. If we are able to see that either of the four conditions don't occur, then we will be able to prevent the deadlock. So, either we can do resource reordering, we can disable hold and wait, and we can allow the preemption so that either of the four conditions can be broken and deadlock won't occur in our system. Combined policy changes with runtime checks are used to reduce deadlock portability while balancing performance impact. For deadlock detection and recovery, resource allocation graphs are scanned periodically or the wait for graphs are used to detect the cycles in the system. Systems are recovered by either aborting all of the processes or rolling back a particular process or preempting the resources from the system. If the resources are to be preempted, then we have to select the victim, that is the which process or which resource is to be selected for preemption. Rest of the things we will consider in the next lecture. Thank you.